Check one. Okay, just doing a mic check. That came through. This is PlayStation Repair Augusta going in for part 3 of what was supposed to be a one-part video of another series. So this basically had to become its own. Starting from yesterday, was doing a Ethernet controller replacement due to a transient surge event that blew that out. Turns out that we also had a issue with the Ethernet port on this, and I had some problems with my multimeter, which resulted in basically, I guess you could say my multimeter was trolling me, but I allowed myself to troll me because the multimeter would be working correct one moment and not the other. This is a cheap multimeter just because, I mean, I use this kind of like a general all-purpose power supplies boards. I probably need to separate those because I've never jacked up a multimeter on a board. I have broken a few on some power supplies. So rather than burning up and throwing away a $300 multimeter, I am blowing up and throwing away a $50 to $60 one. I was online last night, and this morning I'm plotting and planning out my new multimeter. I think I would like to get one that allows me to add that display of the multimeter readings to the screen. So I'm trying to figure out which one is best for that. There's Tech Power, but again, that's a multimeter where it's not the best. And then I'm looking at those that are in the price point of that 50, 60 bucks range that do have it, but their software is really outdated. Found two I really liked, which was Keysight and Hioki, but we're now talking $400 or $500. So I don't know. We'll see what happens. I'll probably go the cheap route and deal with crappy software, or look back more into Tech Power and see if they've made any strides in cleaning theirs up. I know that there's a YouTube streamer, Daniels, I forget his name, makes one, but his drivers are only for Linux, and just for simplicity right now I am streaming off the Windows computer because I can have scope, everything, all of it connected on one machine. Although I think now my Amscope microscope is Linux compatible with those drivers, so I should be okay. So who knows, I may change over. But to get back on topic, I allowed myself to troll myself because of intermittent short readings that were coming through the multimeter. Basically, the short, when it came through, was correct, but it would every now and then just lose its ability to give you that correct reference, and it would basically lock itself into an OL mode and then somehow unlatch from that and go back to giving you beeps. So it made you think when you were probing that, oh, I got a beep, now I don't, I got a beep again, now I don't, that it's functioning the way it should. And I'm still using that meter today. I just now have to be more conscientious about making sure when I don't get a beep that it is correct. And this has probably been a long time coming. I think this is actually a side effect from a power supply diagnostic where I wasn't even repairing it for someone. I just wanted to get some more info on it. And it resulted in let's see, we are not on the same wavelength here. There we go. Now, adjust this top, making your display look as clear as my display does. Alright, so this is our port here. We already know that these, let's just test, there's our beeps. Okay, so now that we've removed this, we've got nothing. And I made more work for myself yesterday by taking back off the IC that we replaced, which probably had no issues with it whatsoever. Definitely not the second one. I think the first one, because we had a hard time pulling it off, was a clear indicator that it had seen a transient and basically just nuked itself. However, the uncertainty due to the readings caused me to doubt whether or not we had a short on two pairs, where this pair and this pair were all joined together. And that actually took place inside of this little sucker. Okay, great. And this one happens to have is that a G-Tech? Is that what it says? Yeah, G-Tech or J-Tech. I guess that's a J, and then they just want to put the sun over it. So J-Tech ports, for some reason, some are branded, some are not. And they probably changed manufacturers to just a cheap no-brand maker. And it's funny because if that's the case, more of these seem to have that problem than the brand. So there might be your one indicator, and the shock, from what I can tell, did not come in through that Ethernet. Or actually, I take that back. I guess it could have, because it still would provide, and this is where, again, it's going to take an engineer to know this part of it, but let's just show you what I'm talking about here. So to recap what we had yesterday, we've got, again, we get beep now. We've got these 4 pins. Remember, it's not on the board. I just showed you that. These 4 pins all are in continuity with each other. Now, this is a ground pin, and it is not connected to anything. It basically plugs into ground and then meets up with the shell ground via those mounting pins that are directly soldered into ground. Now, these 4 pins over here are not in continuity with it, but yet these are. And this just, I don't know why I thought that there was any way in hell this would be possible. But, you know, I figured I got 2 of them back to back that are doing it. Actually 3, including the 2 boards I checked and the one that I replaced with. And like I said, what I realized is that they're all this no brand. And obviously I had a bunch of boards that I didn't realize had Ethernet issues. Some of them I had even powered on and repaired, but only to find out that they had other issues with them that prevented, like one was missing its daughter board, so with no Blu-ray, who gives a crap at that point? It's a part board. The other one, I think, was USB, so it's starting to make sense with that surge on the Ethernet controller that other parts of the systems were affected as well. But usually, like I said, it's always the controller itself that goes, except for in later models where there is no controller. It goes direct into Southbridge and then backs out into the APU. But on the models that do have it, you usually don't get these blown. And I guess that's a difference in manufacturing, and just goes to show how a difference can vary between an off-brand, cheaper component and a branded. Whoever J-Tech is must do a fairly decent job, because we're going to go and take a look at this one now, which is that J-Tech. And you can see even the pins coming through the back are configured different. So it's a completely different manufacturing process. And this one, let's get into the right angle. These 2 are in continuity. But before we move from that, let's go. So continuity. And no continuity, no continuity. We can just slide all the way down. We got no continuity. But if we move over to this pin and we go, where are you? Continuity. but no continuity. And it continues. Now again, the center pin is ground, so it's not connected to anything until it's plugged in. But this, not connected. And then this last one here, wherever the heck you are, couldn't see you. Okay, you're just kind of sticking out there. All right, so that is in continuity with each other. And those are part of the pairs. Now, when I say that it's impossible for a strike to travel straight through, that is impossible. However, because it uses an inductor, you're still generating a current. You're just doing it differently. You're providing isolation, but there's obviously some ramp up, and maybe it is impossible for a strike to pass through that. But I think in this case, we absolutely have. So, where is my stupid thing that I tore apart yesterday into a million billion pieces? And then I probably tossed it about because I no longer wanted to deal with it. So basically, I needed to take a break. I tried to do too much yesterday and spent a little bit too much time out and about while shopping and doing the regular things that people do. And then when I came back, it was just late. My mind obviously wasn't in it. And that just resulted in me creating more work for myself. Somewhere around here, there is this part where I wanted to go back to where we had the coils and show you this inductor setup where the front side and the back side of that are completely isolated. And transfer that data through a gap from what I assume is signal transfer through a coil. And I knew that you could do like your power stuff that way. You know, obviously high frequency switch mode power supplies. You're taking AC on one side and either up or down, converting it on the other. So, I mean, it's obviously possible to use a coil to do that, and then you do have a one-to-one, which is like your isolation transformers are most known for that. So my imagining of this is that it's a one-to-one coil. And I really wish I would have taken a picture, and that's where I need to set up my Amscope USB camera, because it takes pictures and records video. It does pictures better than it does videos, but I bought this other camera, and it does video or pictures, not both at the same time. Once you're connected via HDMI, you only get picture capability from USB, and those two components cannot be used simultaneously. I also doubt some of the stats of that camera being like a true 60 frames per second. Maybe the lens could render it, but and have like the ability to switch and send whatever signals it needs to at that rate. If the lens is, I would think that it would have to play a part in that role. But I've looked at some of my frames per second, even when I had it cranked up, and maybe it is a processing power limitation where the system just won't allow it because it doesn't have enough. But I've never, ever seen that thing clock over 45 frames per second. So, go figure. But for the price point, it was good enough. And like I said, it's not going to be my end-all, be-all camera. This one will switch back over to the inspection side, and then eventually that new camera will take in my top-down microscope here so that we get that wide field of view. And I'm ranting as I'm trying to locate this little piece, and if I don't see it soon, we're just going to give up on it. I mean, I found the pieces for it, so it's odd that I would do something with the main part of it while retaining its pieces. But when you're frustrated, you tend to do crazy stuff. And I was certainly frustrated yesterday. If you're one of those that likes to revel in another person's misery, watch last night's final video. And you'll, I sometimes do a pretty good job of covering up my emotions, but I was ready to slap the piss out of that component. Alright, I really think that we're not going to find this part. Now, there's only so many places I would have stuck it unless I threw it in the trash. I don't think I would have done that because I wasn't done with it, but I did just check as much as I feel like digging through a trash can. I mean, there's nothing but rags and debris in there from soldering, but I don't need it that badly to want to go rooting through it. Alright. I was trying not to have to move all of the board stuff here. I think we don't have a choice. Get out of my way. 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 And alright, still just going through and looking for this part. I just moved all of the components that were a part of this, so I'll have to put those back in just a second. But we'll save that for when it comes time to reassemble all that junk. And let's see, did we find it? No, no, no. Alright, so anyways, it's around here. Let's try to imagine this then. We're going to use a little creative thinking, and we're just going to talk it through without actually looking at it. So here's the thing. This is one of the buttered ones. As you can see, it is got just some gnarly burns in it. This is the one that I tried to manually remove that just did. I mean, this thing was even, it was fighting back on my reflow station. So the way it works is there's a circuit board inside of here. This is just way too zoomed in. Let's see if we can get up. Alright, so there we go. Now we can talk a little bit better here. Alright, so there's a circuit board inside of this, and that circuit board does two things. There is a resistor array that I have not paid enough attention to figure out what it's doing. I just noticed that it was there. But the two main things that it's doing is it's taking the signal from the front side and it's running it through, there's 4 wires, 2 wires attached to each one. So there's one, let's say we have red and green, which is a color scheme that they use. We've got red and green, red attached to pin, and let's just call these pins 1 through 9. So this would be 1, 2, and we're only going to talk about these 2 because it operates the same on every 2 pairs. So we've got a red and green wire on the front side, and so let's say this is our front side. So we've got a red and green wire on one red and one green on pin 1, and the other side of red and green on pin 2, and that actually connects into these guys. So it connects to the actual clip that plugs into the Ethernet. It does not actually directly connect to the pin that goes to the board. Those wires then use inductance to transfer that signal to another set of wires, and let's call those gold and black, because I know gold was used, but I think it was like gold and green or gold and red again. But anyways, but just so that we keep them separate, we've got red and green and gold and black on the back side. So red and green's up front, gold and black is on the back side. These wires are not directly connected to each other. If one of them could possibly share a connection, but I do not think that they do. I'd have to look. No, it would be impossible for them because there is no continuity between front and back. So that is where, at least again, without having the exact reference here in front of me, that's what I'm going to state right now. So gold and black, one of each wire goes to pin 1, the other side of each wire goes to pin 2, and you get that inductance where basically a magnetic induction field can generate, electricity when it's ran through a coil, and that is what it does. And I'm guessing that however they have it set up, it's a one-to-one scenario, so that basically whatever comes through on one side, its inductance replicates that on the other side and uses that air gap as a barrier where the wires are not actually physically touching. And that is a very good way to go about creating an electrical safety to protect that circuit. Now, the question is can a transient be so large that it exceeds that capability and it generates a signal on the other side of that that still is powerful enough to cause issues? Or obviously, would that be some safety circuit inside of there that tripped? And this would answer the question as to whether or not the surge came through the Cat5, or I should just say the Ethernet connection, and then ran down that line and actually blew this up, or because we had such an issue getting that off compared to how it should have been, is it possible still that the surge came through the HDMI and somehow backplaned itself into the Ethernet, even though the Ethernet probably got shocked in itself beforehand? I doubt highly that it came out in the reverse direction and did that damage, but who knows? I mean, you almost would have to be the electricity moving through it to know the path it took at the time without spending tons of money into research, and that isn't me. So I hope that helps clarify any misnomers I may have created in the minds of anyone that watches this in the past, present, or future. That should help it to make more sense from all the crazy issues I was experiencing yesterday. To clarify, at least to my knowledge, now you can use Cat5 wires and twisted pairs in any way you want, for telephone, for different types of data, but if you're following the standards for Ethernet, you have one of two configurations, and they could do something crazy in the future. But as far as I know, you've got a 4-pin and an 8-pin configuration. You're either using all 8 or you're using 4. And if I believe, or I believe I'm correct in saying, that's what I want to say, is that this is a 10 base 100 or a 10 base T100 connection. We're not getting gigabit service from PlayStation because you're never going to get that through their servers. So a 100 megabit connection, and I may be wrong. Maybe no, it can't be a gigabit. It's impossible because that would require all 8 wires. So we're looking at, I'm pretty confident, a 10 base T100 Ethernet setup. Now, maybe on the Pro, that setup is that way, but maybe they see anything beyond 100 as unnecessary, and with that, they want to use that extra wire as the ability to create this kind of isolated barrier. And to be honest with you, I think from seeing the performance that we get from well below 100 megabit connection, that's probably the right decision to make, is that if it requires that configuration to create a layer of protection, I would rather have that layer of protection than the faster performance, because you're not doing gigabit transfer. Maybe if you're transferring from machine to machine, but that is so little of a practice that it's not going to outweigh the benefit of having isolation. So now, and I can look at this and already know that this is our correct one, but because we put it down, we want to probe it and make sure that nothing's changed. And what has changed is my multimeter has turned itself off. So we have beep and no beep on the others. We're going to go to our second pair. We have beep and no beep on the others. We have beep and no beep on the others. We have beep and no beep on the others. And that was a bit redundant. I didn't have to go all the way through, because if we had seen that, you know, over at the halfway point or the 75 way mark, there was no need to check those last two pins. But why not, right? So now, the question is can we get it in? And no, we don't fit. So we need to fix that. And this is where, now that this has been removed and we're just dealing with that through-hole ground plane, hopefully we can get away Alright, so we didn't fit, is what I was saying. I didn't have my camera lined up for you. But maybe I did, and I just didn't after I moved back. But that doesn't fit now because this is plugged up. So we need to make it so that we can get into this. And yesterday was just one of those days where everything you don't want to go wrong with your repair does go wrong. And then when you find out afterwards what exactly was causing your problems, man, it makes life suck. Because it was something so stupid and so simple as just making sure the multimeter isn't being a tard. So the moral of that story would be, always have a backup. Alright, come on, you piece of crap. The fix for this is to pull out that hot air. And also, if I had actually cranked my heat up on my tip all the way, alright, there we go. far away from the device so we can turn that heat up. I've got the camera raised almost to the point of having to be on my tippy toes. And I say that because I'm standing. I like to stand. I don't like to sit while I'm doing this. I don't know why. It just keeps me mobile and I guess keeps me from feeling like a fat ass sitting in a chair all day. Alright. So now we check it out and we fit. Sort of, kind of. There we go. You want to make sure that we're all the way seated. Now, we could go back and do this on the reflow station and make sure that it gets, dropped in, got a little tension on itself, it's pushed in properly. It's probably a little easier to do when the whole thing's nice and heated up evenly, but then you wouldn't get to see it. Alright, so now we're in there. Right. Before we go putting any of this on, let's do one last check. Make sure we got beep. Make sure you can see what's going on. And we're still not connected there, or there, or there. So I think we're good. Now if we hook this up and it somehow magically becomes short, I've got a sledgehammer that will fix all these problems. Again, I said I normally wouldn't do that one, but what I want to do is just because I want to make sure that it's not out of alignment. We're still in. Let's check our front side. We're still flush. So once you get those mounting pins in, this thing really, even if you just get those two back ones, that's such a more grabby surface. If I can make up a way to explain it, that basically it's a larger surface, so it gives a little more bite to its grab. And because of that, it isn't going to go anywhere. We don't have to worry about it. I'm supposed to be wearing gloves. Do as we say, not as we do. I'll put gloves on in a minute. we want to remove that bridge. There we go. All right. Now, before we do those front two at least, because the back ones are easier, we're going to check this one last time. When you get trolled like crazy, oh, I got out of your area there, didn't it? You know, I never checked to see if the stream came through. Yeah, it looks like we're good. So, oh, I adjusted my board because my camera wasn't looking at it, and then realized that somehow I moved the camera and I no longer was able to put my head over it. Alright, so there we go. No whammies. Alright, so it looks like we're good. We finally have no bridges there, where at least they shouldn't be. Alright, so with that, we can now lock down our front side. We're going to put, just because again, this is such a thermal mass here that it does not like to cooperate. We're just going to go ahead and give it a little flux. And turn this heat up. And I'm not going to use hot air. I'm just going to let this one ride. I'd have the heat on this tip all the way up, which I think it maxes out at about, I think it actually can go a little bit higher, but it is at 460 right now. And, you know, that would probably be more than what is needed, except for the fact that, again, this is a cheap tip. And its thermal recovery is much slower. Eventually, I'll do a review on that. Like I said, I keep telling people I got to get my whatchamacallit, my oldie but a goodie, which is the damn, I can't even think of the name right now. It is not JBC. What's the other brand that uses an induction method for heating? So that is called, I forget, and it's up under the desk because I have it in pieces to put back together. But I will figure it out in a moment and share. That thing, I would not, if it had a heat setting. Now their newer Metcal, there we go. Their newer versions do actually give you the ability to temperature control that, but because it was set to the way that they basically engineered the tip would have a preset heat setting. You didn't really have the ability to adjust it. Now they do offer that, but I haven't wanted to buy that different machine. I think it's like $500 or $600 just for the base power unit, and then I can use my same handle and tip. And who knows, maybe I should just go ahead and go that route. But I do like my oldie. I'm surprised that it did break on me because I bought it used secondhand. It was broken. I then took the time to learn it, repair it, fix it, and it was working great for a long time, and then just went out one day. Alright. Still got just a little bit of flux there. Let's dry it out. It's a little hard candy gooey, so it's almost at that phase where it would be considered no longer needing to be cleaned, but I would say that its need or necessity to be cleaned, and I'm just scraping it away, is probably, this is what I was referring to. You can see I've kind of, in fact, you can see the gunk on that. The need for that to actually be cleaned up is probably also non-existent, but I don't know, call me OCD. I just like to make sure it's not there. Okay, so now that that's been done and we know we've got a good one, we've got to fix the other problem that I created for myself, which is I removed the whole original start of this repair. And you know, and that IC is probably good, but I'm not sure if it came off with the same one that I swapped the port from. So let's just grab a different one on one that we know has a good port. What port are you? This is one, I don't think I'm going to do that one because I think this is one I was missing a daughter board for, but I may have ended up finding that daughter board. And the same goes for that one. Okay, give me a second. Let me run to the reflow station. We're going to pull the chip from the board that we just pulled that known good port from. Well, I looked at it and I think that's actually probably the one I pulled the original from. Let's check this and see if these pins are good. Alright, so those are good. So we're going to snatch it from this, and you can tell I've pulled a few things from this and just played around with it. I think this was a profile test board at one point. Alright, so That's the chip we want. You can see this board is definitely one I'm never going to try to reassemble. I've just left parts floating after snatching other things off. And let's see. We want to now use hot air. It already has the right tip. We'll start with a pre-warm. And that helps me, but doesn't help the video. Now, if you're wondering about this board being on top of the other board, I do this all the time. It never causes a problem. If you don't believe me, try it. What we will use this time, though, is our special-made heat shield. And we'll use that to cover up the south bridge as we're applying heat. Although it's not really going to get much heat with this tip on there. Alright, and then that's more than sufficient on giving it a warm-up. And you just do that so that you don't thermally shock the board. You don't want to cause any warping. You don't want to thermally shock the component to where we just jack it up to 400 degrees, which we definitely don't want to get that hot anyway. But about, what's this package probably rated for? I would say you wouldn't want the internal tolerances to go past probably 225, which means externally you can apply that 400 degree temperature to it for a little while before that heat starts to penetrate. So it's not coming off nice and clean either. Oh, that was definitely easier than the last one though. And let's make our orientation easy by not even getting out of orientation. And that is my cell phone going off. So we laid that chip down where it's supposed to go, but we do need to do some cleanup here before we get started. And as I said earlier, I should put gloves on. Go ahead and do that now, so we're going to get much more involved with flux here in a second. Okay. So we just move that chip off to the side while we do some quick cleanup. There's little beeps for my soldering iron talking to me. And basically, even though this has already been gone over and tinned with leaded solder, we're just going to go back over it. Better to do it now than to lay it down and have an issue. And have to pull it back up. Alright. And I'm just spreading it out just so that it doesn't pull in a weird way. Why am I grabbing the desoldering iron when I want the hot air? And we're going to turn this airflow down so that we don't push all of our flux all over the place. We want it to still kind of pull a little bit. And then we want to bring our temp up a little bit. Alright, so I've already kind of advanced it. I'm doing a short warm cycle here because the chip isn't on. Oh yeah, we said we would go ahead and block that out. We got the polar bear protecting our south bridge. Waiting for that ground plane in the center to get heated up. When you talk about thermal loss due to the ground plane, you can see that all those little leg pins are shining. The ground plane is actually just now getting wet, and as soon as I took that hot air directly from it, it went back to not wanting to participate, and I just knocked everything out of alignment there. Okay, so I was reaching for this guy. Don't ask me why. I'm right-handed, so I grab stuff with my right, but for some reason I like to store stuff on the left. Makes for grabbing quite interesting. Okay, obviously my airflow is a little too low. I was on 60 and that just wasn't getting it. Look at that. On 110 actually. Oh, I'm not all the way up either. I forgot. Now we can come down and airflow because we don't want to blow the chip away. We kind of keep everything where it's supposed to be. And are you guys lined up? Even better. Alright, so get us back to a molten state. Plop us in. Do a little tweezer alignment. Put a little pull of flux in there, and we're going to turn our air up and our heat down. And I'm going to do a quick blast of higher heat. And we're going to go back. I don't like the way that laid. It's a little tilted on this edge, so we're just going to try to get it hot enough to give ourselves just a little nudge like that. I like that alignment much better. We probably could have aligned it just a little bit more, but I mean, perfection is not necessary. Let's put some more flux. Oh shit, did you see that? I snatched my... looks like, I think it was brown. It looked a little black there for a second, but that is a capacitor. So we'll have to put that back, but we're not going to do it right now. We're going to do it as soon as all... a little more tin on this tip. A dark spot, so we want to make sure that our tip is nice and shiny but doesn't have too much on it. Alright, that's good enough. Sometimes I want to overachieve with soldering, and all you're doing is wasting your time at that point. Alright. Do a little zoom in here. And what we're doing is we're just trying to visually inspect those connections. You know what? This will be much easier for you all to see, even though I can see it through my scope. Clarity just, I don't feel like is there through the screen. It'll be much easier for both of us to see once we have all that flux out of the way. You know, the more I think of it, I think that probably a autofocus camera, I'll have to talk with that camera company and see if there's one that is the, it's a 20 megapixel IP camera, and it is USB only. I would love to see a way to add autofocus to that, because I don't think it has it. I had to clean this anyway, so I just went ahead and did kind of its final clean. Alright. And yeah, you can see that. Now, those two joints, I'm sure they're probably connected, but they could be a problem. So we want to touch up this side just a little. And I'm a little concerned about how high that may be off of that back plane, and that's why it's not really sitting the way it should. So let's just add a little bit of flux. We don't need a lot for this. Let's zoom back out here. You see our roll. We needed to do that anyway to get that chip to fully seat itself the way that it should be. But we're just going to have some gentle pressure on this chip. And we're going to try to get it to just sandwich down where it needs to go. Alright. Still didn't really do it. I wonder if there was something in that solder. Or are we more connected or more flat than I think? No, we're flat now. Yeah. Okay, we just need to add a little bit of solder. Oops. To this side, and we should be all good. Does not seem to want to bond to that pin, does it? Alright, so we're going to change tips and see if we can get this. And it's probably soldered underneath, but I want to see that nice bead of solder come off the side so that we have solid confirmation that this joint is permanent. And change our okay. And that was all we needed. Having the right tool for the job, that's what they say, right? Pulled out a tip that, as you can see, much thinner profile, much more narrow point. Was able to get up underneath and ensure that there was solder on that pad and that there was enough so that it could kind of create its bridge. And with that, we have now got that the way we need it to be. So let's take out, where is it? I need to bring back up a little magnetic tray for all of these. Oh, I found the stupid thing I was looking for earlier. The part that was hiding in plain sight. Alright, so we moved the camera. That's probably the easier way to go about it. This we definitely want to get cleaned up. And if you're having a hard time getting flux to release from the board, there is a trick for it. Something you can do to kind of speed the process up. First, let some isopropyl break it down. Then, get your hot air, and just put it on a low setting, like 150 to 180. Because as we've all seen, when you heat up flux, it bubbles and boils and kind of becomes a little more soft and pliable until it eventually hardens and crystallizes. And that 150 is a well-safe temperature for components. And even without IPA down, as you saw, that was just a dry rub. And I'm not talking about barbecue. We're just taking a dry Q-tip and we're coming at it. You don't have to worry about the solder getting liquidous at this temp. Now at 180, you get a little bit closer. So I'd probably recommend starting at that 150, and I mean, you could even probably be lower. And flux will get wet at a fairly low temperature. And once you had the bulk of it clean, I should say, come back in with some IPA. And we're going to go over it one last time with hot air, and the reason we're going to do that is so that any of that IPA that's flowed underneath these chips, we're going to basically just dry it out. We're going to force it out from underneath, boil it off, so to speak. IPA already wants to just evaporate into the air, but it does have a balancing point where, you know, it'll just sit there. It's basically once it's moisture content it pulls water out of the air and it reaches a moisture content of a certain level, and then it kind of stabilizes. So at that point, I mean, it will sit there for a fairly long time. Don't just assume that it will completely dry itself out and you'll be done with it just by the air alone. And that's probably overkill on cleaning, but like I said, I'm a bit OCD when it comes to it. And I guess this is where at a certain point, a large enough ultrasonic cleaner could be a time saver. And I guess before I went through all this cleaning, I really should have checked just to make sure we don't magically have shorts now. Alright, so now, as I mentioned, we're going to pull this tip off of this hot air though, because we're going to use that same tip that same temp we were just using. And while we're drying this out, we're going to look at the board and we're going to check just to make sure we didn't accidentally knock any components off. and I think we're good. So, as I mentioned before, because of this now, we're going to switch our camera view and we're going to go into assembly mode. Let me clean up this garbage from last night. We'll also do what I was going to do last night, where we were going to take a look at the thermal paste that I got from Amazon Prime, which is supposed to be a authentic seller. Well, not Amazon, but the seller that they're distributing for is claiming to be an authentic seller. We will find out momentarily. All right. Let's just see. Is that wet? No, that is dry. Trying to see if this little bit of liquid here is moving or if it's stationary. And I think that looks dry. That doesn't look like it's traveling with the cotton ball. It looks like it's staying put. And that's what we want. Like I said, if it was wet or sticky and it's not showing signs of a bunch of this stuck to it. So, you can see that has a little bit of tack, but not a lot. Alright, so we're good on this. We're now putting our parts. I had to kind of collect my thoughts here and see where we're at. We got parts here for reassembly. And there we go. Alright, so just to show, and let's go in here, we've got, I said before that this was Didogu. There's actually a name reference there, but I'm not going to give the customer's name out. And the ticket number, 4282. Alright, so, same board from yesterday. Obviously, we had all the same issues. Let's check out these pins and see if we have a reason to pull out the shotgun and murder this board. Let's get this whole thing in view here. Alright, so these pins should be in continuity together, and that helps if you're not in sleep mode. And we're good. We have no continuity there, but we do have it here. And we got no continuity here, but we do have it here, which is what we want, and not there, and there, but not there. So we're good. Nothing changed, which is the way it should be. So we now know that we have good ports. Hopefully we've got a good chip. I mean, we really don't know until we turn it on. I could go through the data sheet, and if we do still have a problem with Ethernet after this, that is probably my next step. But I'm no longer as frustrated as I was because we're not dealing with a stupid, what is it called? Stupid, oh, and I needed to switch the view. How did I have this? I'm just changing my camera because I had not remounted it since yesterday. And we need that aerial shot. And that would be how do I get this to stay? Okay, maybe that was it. Or not. I think we were like that. Or not. Let's see, can we get a little more forward? There we go. All right. So now everything's over here. We'll show this again just to show there was no switch there. Same board. Edogo 4228. What did I say? 4285, 86. One of those. Anyways, 4282. That's what it is. I'm looking at it upside down. All right. So that we did have on this one where we talked about last time that we needed to clean this out, and with this one it's got so little we're just going to use just a little horsehair brush. We're going to get down in it, make sure that those fans, or sorry, not fans, fins are cleaned off. I don't see any dust on that. I think I already cleaned that last time. I cleaned it from the other side, obviously, because I didn't remove it if you don't take this out. Or if I did take this out, I did not clean the fan when I did it. Or clean the heatsink underneath. Alright, so that, now we need to put this back in. So, alright, again, we didn't take the Blu-ray out. It's still in the tray. We didn't remove the fan. It's still there and has its connector. The orientation of this is kind of self-explanatory. If you put it on the wrong way, you're not going to be able to access your fan cable. But there are 3 screws that go in here. 2 screws on this model that goes into the fan. So you put those screws into the fan first, then you put this down, and then you're going to be able to screw this in. Let's get our screwdriver here. Again, just a regular old Phillips. Using a little precision screwdriver bit set. So that is 2, and now we've got 1 more to pop in there, and this will make number 3. And next step will be to clean our heatsink. I like to clean it with a Q-tip first, and then I come back over it with a flat cloth or the flat Kimtech wipe. And you know what? Before we actually put anything down on this, let's see if we're going to be able to use this new thermal paste. And just so that we're going to take this donor board, move that out the way. We're going to now check this out. I already did this. Obviously, you'll see. Should have saved the unboxing, but this is how it was shipped from Amazon. You guys make no damn sense. That's it. Now the packaging on this looks good. Everything is the way it's supposed to be, but cloners are pros. I mean, you get lazy cloners and you get good cloners, so let's see what we got. Alright, so can't read any of that. Arctic Silver 5 is what it says. Oh, I'm already not liking what I see inside of this. You know what? We've got our aerial shot, but we're going to do this. I'm going to bring this camera over. We're going to go back to our... let's go scope big. Alright, this color isn't even right on the inside of the cap. You can't see that. There's the inside. That's not correct. If my memory serves... Oh, and that is not correct. That is hot, wet soup. Okay. This is garbage. Yeah, this is not... No. No, that's fake. That is definitely fake. This should be dark. Dark in color. It should be less gooey. And it should have almost kind of a metallic-y appearance. There should be like a glitter effect to it, but not glitter. It's that metallic kind of resin, particulate kind of shimmer, I guess is a good way to put it. That is the lowest of the lowest quality of Chinese garbage thermal paste. You don't want to use that. If that's what you're getting, this thing had huge reviews. It had like 200, 300. It was an Amazon Prime recommended. And I mean, call me out on it if I'm wrong, but I'm calling bullshit. Bullshit times 10. Let's check the other one. Maybe they do you one good, one bad. Look in the cap. Nope. Same gray poop. And this stuff can be good. I mean, that could just be that, you know, it's been sitting stored forever, but no, that comes out way too soupy and not looking right. That's not, it's oil based. The stuff that Arctic Silver 5 is a polysynthetic blend. I believe it's Teflon free. It is actually a 3M product that makes the base solution. So they don't even make that. They just buy that from 3M. Then they mix in the thermal compounds that they want to have mixed in with it, and that is how they make their thermal paste. It's not like they're doing rocket science, and I don't know why, if you want to clone a product like that, you couldn't clone something of quality. I mean, this stuff isn't expensive. This is a huge profit margin for manufacturers, and when they sell you crap and bottle it as premium, they make an even bigger one. And I guess the profits just are too tempting for somebody to not grab a hold of. But that's going back. Amazon, you're about to give me my money back. I've seen shits that have come out that look better than that quality. At least a poop is firm. That stuff looked like running water. That was diarrhea in a tube. Alright, so what do we got? I wanted to show, where the hell is mine? We're going to bring this back over. Well, I shouldn't bring that back over, but that was where my thermal paste was. And this is actually, now I used up all of this. Where is it? This is the Arctic MX4, and this was good stuff. I bought this off Amazon. Like I said, they're vendored up enough that you find good providers of this. But that is not theirs inside of it. I actually refilled that from this company, which is a Chinese company, and they make good quality thermal grease. You can't see that, can you? And they sent me a sample kit, and I really should respond to this guy, but some of their claims and its competent, it does perform, and I guess to some degree you could say it performs better than Arctic Silver 5, but if it's the legit stuff, the one thing that I think that Arctic Silver 5 has an advantage over this is that their product using that 3M polysynthetic blend, whatever, I forget the material is called, it doesn't separate. It's very good at binding, and the materials don't separate over time, so it's dry. This one will dry out faster than what I think the Arctic Silver 5 was. It also can be a little bit more runny at times, and that's where we talk about like settlement. Like if you look down inside, let's see if we zoom out here. Okay, so see how we've got kind of like thicker, and then we've got kind of really wet in there in the corner where it's kind of secreting out of itself. This is really good stuff, and thermally it does at higher temperatures, it performs better than Arctic Silver 5. But at that medium temperature where your PlayStation should spend most of its time running, I think the Arctic Silver does perform a little bit better throughout that fuller range, I guess. But the max on this outperforms that Arctic Silver 5. So if you're overclocking, then this may be the better product for you. And actually now, PlayStation Pro and the Xbox One X, I mean, they squeaked out performance from those via overclocking them, which I don't really think is an answer to the question, because overclocking requires better cooling than what these manufacturers are going to provide to the average consumer. And so I think we're going to see that it becomes a big service issue in like that 2 to 3 year range. But only time will tell. And I may be wrong, but I think I'm going to be very busy with those consoles in about a year from now. Alright, so we have now, and again, I'll just show this one more time, 4282, still the same. And we're going to swap our view. And Logibig only. Alright. So, we don't have thermal paste on here now, and we also don't have a battery, because we're putting in a new battery, not the old battery, because if you remember from one of my previous videos, I grabbed that bottom or positive and negative with tweezers, and that doesn't work well with electronics. So that battery is now dead. In fact, that battery is right here and behind the back into the trash. Alright, so we got a little bit more cleanup to do on this chip. So I've showed before cleaning this chip off, so I'm not going to go and bring the camera in on a zoom just to show something that's already been done. I'm just cleaning out the excess that was left behind. And now we're going to take, this is that Hausheim I cannot pronounce that at all. And we're going to do the P method. Or you know what? I may show you both methods. No, we'll save the other method for another time. I'm not going to look for a card. We're going to keep this rolling because I do got other repairs to move to. And now with mine, I like to do it like, I think like froyo. I'm taking and making a ball pea, but because it stays stuck to the tip, I swirl it, twirl it, whirl it, and pull it. Once I get it up, all I have left is, can you see it? No, you can't. Let's go ahead. We're going to for giggles here. Alright, so it looks like this. I kind of swirl it so I just get that left on, and then I'm cheap so I don't want to waste that, so I just suck it back in. Put a tip on that later and it will be good to go. So you can see this doesn't take a lot. I mean, if you overdo it, you could end up squirting it all the way into these little components here. We've got some array, whether those are resistors, capacitors, whatever. But these are array chips where it's basically, it's probably a resistor array. But anyways, they're stuck in a line together, all one component but multiple connections. And then we've got some capacitors that are there as well. But if you get it in there, it's not a big deal. It's just going to be a lot of cleaning. But without a microscope or something to zoom in, you'll never really be sure if you've left something there. And for the most part, it won't cause a problem, but eventually, if enough stuff gets stuck in that, the capacitance of the stuff that becomes adhered to it could cause you issues down the road. Alright, so we're going back to Logibig only. Sorry, that's my code name in my views. And what we're going to do is now put this in, and we need to make sure that we have one more of these go in there. Take a look at that. These are heatsink pads for your RAM chips, which are what these are. And you want to make sure you put those back because RAM does get hot. If you don't have those pads there, it won't be properly thermally conducting, and you could run into issues. Have I ran machines without those pads before? Yes, I have. Has it caused them to immediately go tits up? No, it hasn't. And finding thermal pads for the other side. They're stuck between, they're still on the board on some, and then they're on the heatsink on the other. Then two of them have disappeared somewhere. Oh, I found one of them. And then for the last one, get the right size, I've got replacements. Actually, nope, I take it back. I found the original one. Now, some people say to replace these, and I normally would, except for these are in such good shape. And And I will say that the ones the manufacturer is buying do perform a little bit better than the aftermarket ones. I've looked at buying these from the same supplier, and you got to either buy a buttload or you pay a fortune for them in the small quantities. And manufacturers need to stop this crap. Stop buddying up to these big vendors. In fact, if anything, set your price point based on them. But for the little guys, you know, you say you're a charitable company, but when the small guy calls you up, you jack the price up to an unrealistic number so that I guess when you do like government contracts and things like that, you can say, oh, well, we're giving you this discount. No, quit doing that crap. Have a small business price. There's no reason why this sheet, which has 100 pads, cost a couple of bucks. And if I wanted to buy that same thing from this manufacturer, and I forget the name, it starts with an H, or no, an F, no, an L, it's Layer. There we go. If I want to buy that from Layer, I got to go through like DigiKey or somebody, and we're talking like $20, $40 for the same sheet. That's ridiculous. 20, 40 bucks for a sheet of some thermally conductive pads. That's bullshit, and I'm calling it. That is you pricing individual customers in order to justify your discounted price, which actually probably should be your real price, to manufacturers. Just tell them piss off when they say they want a discount. Everybody pays the same. Or, like I said, actually be a true charitable company and promote small repair shops and electronic hobbyists by giving them a price point specifically for their market segment. All right, so now that all of those pads are on, as you can see, oh, in fact, there was one still stuck. Oh, that is that one. That did go there. I was thinking I had them doubled up. That is something you want to check and be aware of. If you're doing multiples of these and they end up getting a pad stuck to them, they're black on black, so you don't really notice them. And then you pull one of these and it's got pads on it already, and then you lay it down, and now you've got this uneven surface, and you're creating more pressure on those pads that have doubles than the ones that have singles. And I've seen this done by customers, by other shops. I've done it myself, but now I've made the note for myself to be aware of it, to not do it, because it's definitely not good to do. Alright, so as you saw, I just slid, and I went ahead and put that in. It just makes it where I've got less going on here. But this is literally all there is to it. We just slap these down in layers, and now we're going to start adhering it all back. And we'll save that for last. We're going to go here and here. Alright, so we get the right tool. This time we're back to our security bit. Because yes, PlayStation and most other providers use security bits. I mean, it doesn't really keep you out of the machine. Obviously, you can buy the tool on your own, but it is designed to make it a little bit less inviting for you to open up, because they really don't want you inside of it. They don't want you in here messing around. And I can't say that I don't blame them for that, because what happens, and even I get it, is where a customer will call up and say, this is broken, it was never broken before, and you're gonna fix it, or you're gonna buy me a new one. And really all along, they knew the problem existed. Or they call you up 6 months, a year, 2 years later, and although it had worked perfectly that entire time, somehow automatically now it was the last person who touched it other than their own hand's fault, and it needs to be fixed. So if I get that, even as a small company, I can't imagine how much PlayStation would get it. However, there are a lot of things, and this is, I think, the real reason why, and I don't know if nobody has just come out and say it, but I'm going to say it, is that Sony, Apple, all of them, the real reason why they don't want the access to schematics, why they don't want us inside of the machines, they want us to take everything they say on blind faith, is because they're human and they screw up. And when they screw up, they want you to be able to hold them liable for it. They want to hold their profit margins. Oh, Vacuum tried to suck up the plastic. They want to hold their profit margins as high as they can, which, I mean, makes sense for any company that's publicly traded. That is why they don't want us having access to this, because the fact that we do on Apple more than anyone gets exposed for the things they do wrong, because the market has leaked all of their information, and we've got enough people tackling those problems that we can eventually say with definitive certainty that it was their fault. And they don't like paying out that bill. But that can be a whole conversation in itself. I mean, we could probably start some wars with those words. But to get back on topic, so basically we put in all of these security screws, and they're just the little round silver screws, and they go all the way around the perimeter. Sony is kind enough, and they do this to help out their assemblers, that there are arrows where all of these go. Like I saw that I missed one, and just to double check, I looked, and I saw an arrow. So there's an arrow right here that points to where that goes. And every single one of these has an arrow. If I'm a liar, I'm a liar, but this one may not, so maybe I am a liar. Nope, there's one there, and I can't see the one here, but I had a void sticker there, so maybe there's not one on one of them, but definitely one goes there. Alright, so once you got that perimeter done, and it kind of goes here, I actually was talking and screwing and wasn't paying attention, and I put one where I shouldn't. So we want to leave that one open, and this one here, there's actually one that goes into the plastic here, that's going to seal down that top. So we want to leave those out. We're going to come across now, and now this is a little different on different models, but for this model, the little plastic tings that are sticking out here, there's a pressure clip that pushes down on that APU to make sure that thermal paste has good contact, and that is actually underneath. It's not on top or in the other. You actually have this underneath the grate, so for different models it's a little different, so don't get confused if you've got a different model. And then we take that. Now these screws that go into this little pressure plate here are slightly different, and these are the same, but one's black and one's silver. You should only have silver in this model, but when I put this back together, the black one, it's the exact same screw, just a different color from a later model, so I used it. So again, if you see that you have two silvers and you're looking for a black, it's just because I did this. Yours is going to be two silvers. And again, that is for the SAA model and the SAB model. I think starting from the SAC model, you get two blacks, and then in the SAD model, you get black and a silver. And the SAE model, I think you're back to two silvers. So don't let color trip you up. You can't count on that. You're going to count on knowing what screws came out of where. And if you're not certain, and you probably need to find somebody, and these are just Phillips, so I just pulled the other screwdriver, and we're just screwing that down. Now I don't like to all the way tighten one of these. I halfway go on one, and then I start on the other, and then I come back, and I just do that to make sure that I'm not putting uneven pressure on it as I'm tightening down, because we want a good straight mount so that we get even pressure, and as we're pushing down on that thermal paste, we get a nice even distribution of paste. It doesn't start to flow one side heavy versus the other. Now that that is done, we've got our next step, which is, actually before we do that, we're going to put the screw in that locks our hard drive tray. You can't really see it. There it goes. You can see it right here. Just a little screw. And again, these are on different locations on different models, but for this one, they're easy to recognize. They have a screw head which has the PlayStation button logo on it, so the square, triangle, circle, and X. And that is all you need to identify that part. Now we're going to flip it over and come back to our bottom side where we never took out our Blu-ray. It's there, been there, will stay there. you have this ribbon cable, and the way these work is you just push down on the button and then they pull out. But like I said, we don't need to exit this, but it was easier to show on that one. There's just a little flat tab. You just push on it. Then you take this one, and when you go to insert, you don't need to push the button. It's pressure locked. You just push it in, and there's a black line on the blue tab that should kind of let you know that you've gone in far enough that you are locked into place. All right, now that is done. And then we need the battery. Sorry, power supply, not a battery. Those are two different things. Alright, so what you saw me do here is there is a connection cable, and this is kind of like our standby on-off switch pins, which send the signal to tell the power supply to engage its 12-volt rail, which is here. These are these two prongs sticking up, and they insert into this, and again on different models it is a slightly different location. You can kind of see the silver in through right here, and there are just two look like little vertical prong lines that then punches into, and it should slide in nice and easy. If it doesn't, you probably have a an issue with the little prongs that are sticking up from the board have probably gotten warped, and so you just want to straighten those out and you should be back in business. Alright, so we have this connected. We have two other parts. It really doesn't benefit us at this point to put them in because these are not connected until the casing is over it, and we're not going to worry about having it fully assembled until we have it tested. Why am I taking that out? I've got a completely separate screwdriver for that. Alright. Alright, so these are the two kind of wide. These bridge the ground planes between high and low voltage sides. They use this back plate here as their kind of intermediary connect, and eventually PlayStation did away with that. They realized that that probably wasn't the best method, but it does work. You just want to make sure when you put it back together that these have enough upward deflection that they're going to make contact with that plate there. So now our next step will be to pull in some power. As well as our monitor, and I'm going to first connect to this, and if it doesn't work then we're just going to go ahead and end the video because I do have a repair that I promised someone I would get done, and I need to jump on that. But as long as everything goes well, we should be alright. I got plenty of time to do theirs. Let's see, I want to now just power on. What am I thinking? Okay. Now, what you just saw me do was I did a manual switch because I don't have the top install, which has the contact switch. So I just used my finger to cause it to conduct electrically, and that should get us going. And we have our first issue. What is going on here? Did I grab the wrong power supply? I don't think that's the case. We were close to that south bridge. This thing is going to be a beast of a repair, isn't it? And this is where you can end up down a rabbit hole, and sometimes I like rabbit holes, other times I don't. But I'm wondering if we had a problem now with Southbridge because we've got nothing but a beep coming out. And if our power supply is good, then our issue is board level. Yeah, we're getting no spin and a beep. I think we might have a problem with our south bridge after all of the pop on, pop off that we had to do. So it looks like, yet again, part 3 has been a partial success. We've got a no more shorts on our Ethernet. However, we've got a new issue. As long as I didn't grab the wrong board completely, but no, we verified those codes on there. So I'm going to have to check this out a little bit later today, and then I will again do another video with this one. I'm determined to get this entirely done from start to finish. However, just to show what our next steps of the assembly would be, that would be for this part, always go on antenna first. I don't know if you could see the antenna with all that was going on. Oh yeah, it's in the right. Okay, so antenna first. I had to wait for the delay to catch up. And you want to come at it at that upward angle, and then you just rock it back. And when you do that, that pops on. And for the other side, you're going to do the same thing. You're going to start at the back and get it. So you got this corner. We're going to get it in there. And then once it's like that, you just take it and you pop it down. And it will lock into place. You want to hear it click. I'm not going to click it right now because I have to now take this back apart. So we're going to figure this one out. And there will be, what are we looking at? Part 4 of this. Technically, it's a completely separate. I would say our Ethernet repair is now good. I do need to check that chip, and if that chip ends up having a short on it, well, then I replaced it with a bad chip, which is why we're not getting anything, but I doubt highly that that's the case because I think we would get fan spin. I think we probably ended up with an issue on our south bridge, and we're going to figure that out. Okay, again, that's it for this part of the video. If you learned anything, if you enjoyed what you saw, let me know. Send a thumbs up. If you have a question, feel free to post it in the comments section. Eventually, I will get back around to this video and answer that question. If you'd like to see a different video of a repair that has not been covered, let me know, and that could be the next video that we do. Other than that, have fun, and there will be more to come.